Hello, my name is Mathieu Liénard and welcome to the second episode of my demo of doing live sentiment analysis of tweets using machine learning. In the previous episode, I used AWS built-in service, AWS Comprehend, to do the live sentiment analysis of the tweets. Since then, I've tried to develop my own sentiment analysis using several machine learning algorithms, which I will discuss here. Before I show you the algorithms I tried and the results, I must give credit to Ricky Kim for his series of articles titled Another Sentiment Analysis with Python, published on the website towardsdatascience.com, which I partly reused. Also, to train my model, I used the dataset available on Kaggle of 1.6 million labeled tweets. Finally, I must mention that I will not present here all the data cleaning I performed on the dataset, on the tweets, before training my models. I will focus on the different algorithms I tried and the result of the final algorithm I put in production. So this is the first model I used, which is a combination of a count vectorizer with logistic regression. Here is the results that I got with an accuracy on the prediction of the sentiment of the tweets of 81%. The next thing I tried is, instead of using the count vectorizer, is use a TF-IDF representation of the tweets together with logistic regression. The result I got using that method was 82%, so just 1% more. So I used the TF-IDF representation of the tweets to try other models and compare the result with logistic regression. So logistic regression, I had an accuracy score of 82.4% of the prediction of the tweets. And here you will see all the different algorithms and the results, so 81.8% for SVC, etc. So I made a plot of the different algorithms. So you can see that logistic regression at a bit more than 82% was the best performing algorithm compared to AdaBoost, which was about 70% accuracy on the prediction of the tweet sentiment. Next, instead of using TF-IDF, I tried word2vec. Just quickly, for the people not familiar with that algorithm, the idea is to represent the words as a vector. You can see one here, representing the word in a multidimensional space. What I also tried is represent the words in vectors of different sizes that you can see here. So I tried vectors of 50 dimensions, 100 dimensions, 200 dimensions, 300 dimensions. And then I ran logistic regression on each of the different sizes and see with which vector dimension I perform best. So if I look at the results with a vector of dimension 50 and logistic regression, so the accuracy score of the prediction of the sentiment of the tweet was 74%. With a vector of dimension 100, it was 76.2%. With a vector of size 200, it was 77%. And with 300, it was also 77.8 instead of 77.4, which is still lower than what we achieve with TF-IDF and logistic regression. What I try next is to perform the same tests, but instead of using the word2vec algorithm part of the scikit-learn library, I use AWS built-in algorithm, which is called blazing text, to compute the vector embeddings, which is the one you can see here. And using that vector representation of the words computed by blazing text, I was able to get an accuracy of 79.3%, which is 1.5% better than the scikit-learn word2vec plus logistic regression. Still using such a word embedding with logistic regression, I was underperforming, so I then switched to LSTM neural networks. The LSTM neural network I use through the next set of tests is the one that you can see here. The problem is that neural networks require a lot of computing power, and the more features you have, the more computing you need. So although with logistic regression the accuracy was 3 points better with a 300 dimensions vector compared to a 50 dimensions vector, for the rest of the tests, I use 50 dimensions vectors to train my neural networks. So I trained the model and I achieve 77.3% on the validation dataset. But to compute the words embedding so far, I used the blazing text default parameters. So the next thing I did is use AWS Sagemaker to perform an hyperparameter tuning job, asking the job to try different combinations to try to find the best combination, the best value and best combination of those hyperparameters. The result is the one you can see here with the different values of the different hyperparameters. So then I use those new values, optimized values, to train a new version of the blazing text and use that optimized vector representation of the words to rerun my LSTM model on top of it, and then I achieve a 82.4% accuracy, which is the same than what I was achieving with TF-IDF with logistic regression. So after optimizing blazing text using a better combination of hyperparameters, the next thing I could optimize was obviously the LSTM neural network. So I did the same thing, running an hyperparameter tuning jobs on some of the LSTM neural network hyperparameters on this time only 30 training jobs, which you can see here. The one without values is because they timed out after 6 hours, so basically it took too long to compute. So same as for blazing text, Sagemaker gave me the best values it found for the hyperparameters. So based on those optimized hyperparameters, I retrained the LSTM neural network, which you can see here. Over 15 epochs, and I achieved 83.5 accuracy on the validation dataset. So 1.1% improvement. Finally, I was able to perform better with the LSTM neural network than the simple TF-IDF with logistic regression. I'm sure it could be improved further by using a bigger vector embedding, like we've seen with logistic regression, and trying a different LSTM architecture. But for the purpose of this demo, and in the interest of time and money, I will stop here and use the best model I developed so far and deploy it in production and test it with live tweets. So I deployed that final model based on blazing text on my optimized LSTM neural network. The architecture is the same than when I was using AWS Complement to do the sentiment analysis, except that my Lambda function, which is run by Firehose, instead of asking comprehend to do the sentiment analysis, is making requests to my Sagemaker endpoint, which you can see here, taking requests and making predictions. So like in the previous demo, I'm streaming here the tweets about 6 different European soccer teams, and counting the number of negative, positive, and neutral tweets per team, and showing this in my dashboard all live. So that's it. Despite you haven't seen all the details about all the algorithms I've tried, you've got an overview of the process I went through trying these different algorithms to the final algorithm, which was a combination of AWS blazing text and an LSTM neural network. It was a good experience and good learning. I hope you enjoyed this video too, and see you next time for the next video. Thank you for watching.